Integer exponents. What is an integer and what are parts of a power? Well, first of all, let's talk about what an integer is. An integer is a positive number, a negative number, or zero. And we'll get into parts of a power here in a second. First of all, part of a power is something called an exponent. And we know an exponent is something that shows repeated multiplication. It tells us how many times we're going to multiply something. Here we have what a power looks like. A power contains two parts. It contains a base and an exponent. The base is the larger number found here, and the exponent is the smaller number that's a little bit raised and usually to the right side. Now, when we're looking at something like this, 3 to the 4th power, and here we're doing positive exponents, so we take this and we say, well, that is 3 4 times. We can take it apart in knowing that we have 9 times 9, and 9 times 9 is 81. So we can simplify 3 to the 4th power down to 81. Now, again, we can take a look again with positive exponents. This is 5 squared, meaning 5 times 5, and 5 times 5 is 25. So it's pretty easy to know what to do when the exponent's positive. Just write down how many times you have to multiply it, and then start multiplying. Now, when we take a look at negative exponents, we have something a little bit different. Negative exponents tell us about a small number. So let me give you a hint of what to do with them when you see them. When the exponent is negative, we know the power is located in the wrong place in that fraction, whether it's the numerator or denominator. So we're going to move it. We have to move it first, then we evaluate it. You cannot evaluate a negative exponent. You must move it first. So if it's in the numerator, move it to the denominator. If it's in the denominator, move it to the numerator. Once it's moved, then the exponent becomes positive. Once it's positive, then we can treat it like we just did a moment ago with positive exponents. So here's an example, 8 to the negative 2. What this is saying is that that's in the numerator, so we need to move it and put it into the denominator. Once it's moved, again, once it's moved, it becomes a positive exponent. Now we can treat it like we would any normal problem. 8 times 8 is 64, and we're able to simplify. Here's another one, just the opposite. 1 over 8 to the negative 2. Again, this is in the wrong position. So what we need to do is move it to the correct position. So when we move it, it becomes a positive exponent. Put it over 1. And all I have to do is simplify. 8 times 8 is 64. And there's no need to put it over 1 because that's just extra pencil strokes. And this is as simple as it gets. Okay, let's take a look at one more problem, kind of mixing it all up together and seeing what moves and what doesn't. Here we have p to the negative 9, q to the negative 4, all divided by r to the 2nd power, s to the negative 3 power. So what that means is, when we look at this p to the negative 9, which is in the numerator, it doesn't belong there. It belongs in the denominator. So let's move it to the denominator and make the exponent positive. The same is true for q to the negative 4. Again, in the numerator, not correct because of the negative sign. So we're going to move it to the denominator and put a positive exponent on it. Now we're looking down here in the denominator, and it's already r squared, and that 2 exponent in this power is already positive. Well, if it's already positive, we're not going to move that. Since it's in the denominator, we're just going to leave it exactly where it is, leaving us with s to the negative 3, again, not in the right place in the denominator, needs to move to the numerator. Once we do, the exponent becomes positive. So we've talked about positive exponents, negative exponents. Here, let's talk about zero exponents. Now, in zero exponents, any base to the 0 power equals 1. So if I have a base of 3, 3 to the 0 equals 1. I have a base of a variable, in this case a to the 0 equals 1. It just doesn't matter. So let's take a look here. I have 5a to the 0 power. So really what we're saying is 5 times a to the 0. Well, we know a to the 0 equals 1, so 5 times 1, we end up with 5. Looking at it one more time, here we have 3 squared x squared y to the 0 power. We're going to simplify this. We know that 3 squared is 9. The x squared, nothing happens to it, times y to the 0, which is really 1. 1 times 9, it stays 9. So this is as simple as it gets. Now let's talk shortly about the negative sign. And we got to remember that the negative sign is that it's equal to negative 1. That kind of helps us decide if something goes positive or goes negative or what happens to it. So here in this first one, we have negative 3 and the whole thing squared. We can look at this two ways. Remember, since this negative sign really is a negative 1, we are looking at, inside the brackets, a negative 1 times 3, and we're squaring it. Well, what that's telling us that we need two of these. Negative 1 times 3, negative 1 times 3. And we can see by that with only two negatives, that makes it a positive. So this totally reduces down to just positive 9. Now, if we take a look at this second one here, where the negative sign is not inside the parentheses, but it's outside. So we take a look at what's happening inside the parentheses. So a little bit of order of operations here. That negative sign, which is negative 1, is just going to sit there. Inside the parentheses, we have 3 to the second power, which is 9. Negative 1 times 9, it stays negative. Negative 9. Here, this looks a little bit different, where the 2 is on the outside. So again, same thing. This will be squared, not involving this. Negative 1 times 3 squared, which is 9, which would give us negative 9. One more to look at. I didn't have it on here, but let me add it. What if it just looked like this? Well, here again, this 2, this power of 2, this exponent of 2 is being attached only to 3. This is a negative 1. So when we look at this, we are looking at negative 1 times 2 3's. Again, staying negative would give us negative 9. So it's real important to kind of notice what's going on with the negatives, where they're located, so that we can treat them appropriately.